Today we're going to discuss the theory of consumer behavior, and more specifically, utility theory, difference curves, and the concept of a budget constraint. The utility function is an algebraic expression that allows us to rank consumption bundles or combinations of goods. So we say the total utility is the quantity of one good multiplied by the quantity of another good. In this case, we're going to use hamburgers and pizza as our examples. So the quantity of hamburgers times the quantity of pizza yields total utility. This approach is assuming that the utility is measured the same for hamburgers and pizza. So one thing that you'll learn about economics is that we tend to operate under a variety of assumptions, and I'll try to keep you as updated on those assumptions as we go through the book. Ranking total utility, so if you look to the left of the chart, you'll see we have three bundles. And the bundle, remember, is a combination of goods. So we've got bundle A, B, and C. And in bundle A, we're going to have 2.5 hamburgers and 10 pizza. So we multiplied 2.5 times 10 in order to get that 25 for the total utility. Same with bundle B, we multiplied 3 by 7, and in bundle C, we multiplied 2 by 12.5. So what we're looking at, how do we rank these? So total utility, the greater the better. The more satisfaction that somebody gets, the better off they're going to be. So in this case, we're going to rank bundle A and C over bundle B because 25 is greater than 21. However, since bundle A and bundle C yield the same utility, we're going to be indifferent between the two. So we don't care if we have bundle A or bundle C because it yields us the same amount of utility. Marginal utility is going to be the change in utility derived from an increase in consumption of a particular good. So the marginal utility of hamburgers is the change in hamburgers, so that triangle denotes change in utility divided by the change in hamburgers. So triangle, in our case, stands for change in, and we'll use that quite a bit throughout the course of the semester, so it would be good to remember that. So the change in utility divided by the change in hamburger give us this marginal utility concept. The law of diminishing marginal utility is as you consume more successive units of a good, your marginal utility will decrease. And this is going to correspond with a homework assignment that you'll have for this week on the D2L system, and it's going to ask you to illustrate this law of diminishing marginal utility. So imagine yourself walking through a desert, and you don't have any water, and you're walking, and it's hot, and you're thirsty, and all you want is a glass of water. Finally, you get to this oasis, and you get this first glass of water, and it's got to be the best water you've ever drank in your entire life, and you hungrily gulp it down, that glass of water, and you would probably rank the utility for that as 10. It's going to be, the best glass you've ever drank. If you ever walked through a desert, if you've ever gone a long time without having the ability to drink something, you know that it's really good when you finally get to. So you like that one so much you drink another glass after that. So you're on your second glass. The utility might be still the same. It might end up being that you're going to rank that as 10. So you drink another glass, and you're on your third glass of water now, and maybe it's not quite as good as the first two. So your utility might go down to an 8 or a 9. And what we're illustrating here is as you keep drinking more units of a good, so successive means in a row, so you have to keep, if you start drinking water, you have a glass of water, you must immediately drink another glass of water in order to completely illustrate this concept. And eventually, the marginal utility or the satisfaction that you get out of this good, drinking these goods, or eating these goods, is going to decrease. So one of the easiest ways to be able to complete this assignment is to use some sort of food product. So eat a bunch of candy bars or successive pieces of pizza and be able to rank them and eat as many as you need to in order for your satisfaction to finally start decreasing. And for some of you that might be 3 pieces of pizza, and others of you that might be 10 pieces of pizza. So keep that in mind when you think about what product to use, that you do have the ability to buy quite a bit of that product if necessary. An indifference curve is based on a notion of iso-utility curves. So we're talking about equal. So iso is Greek for equal. And so we're looking at combinations of goods along this curve that we view as being equal, or we are indifferent to the changes between the combinations. And when I show you a curve on the next page, it'll be a little more apparent. So I like pictures. So here we go. We have indifference curves or iso-utility curves. They're known as the same thing. So depending on where you go from here, what other econ teachers you end up with, you might hear one or the other. But they mean the same thing. And what they're showing is that I2 versus I7. I2 gives us 200. And what that is 200 units of utility. So 200 units of satisfaction. And the other one would be 700 units of satisfaction. So I2 is our first curve, which has points M, Q, and R on it, and I7 has points N and P on it. And if we move from I2 to I7, looking at it numerically, we can see we've gone from 200 to 700. So any sort of rightward shift with the indifference curve is going to give us an increasing utility or increasing satisfaction. So most of the time our goal would then be to be on the farthest rightward utility curve that is available to us. And we're going to look at putting this together with a budget constraint, because money is unfortunately an important part of our society, and we're going to learn how to choose the best satisfaction given a budget constraint. So we're looking at something to look at on the indifference curves is the slope, and we call the slope of the indifference curve the marginal rate of substitution, shorthanded as MRS in your book. Marginal rate of substitution looks at the change in tacos divided by the change in hamburgers. So it's going to be the change in one product versus the change in another product, and your book uses tacos versus hamburgers. So what we're looking at here is the number of tacos a consumer is willing to give up for an additional hamburger. So if I want to get one more hamburger, how many tacos do I have to get up in order to stay on that same amount of satisfaction? So that same utility curve here. So we're looking from going from point M to point Q. So we have our change in tacos. We're willing to give up 2 tacos in order to get one more hamburger. So the change in tacos was 7 minus 5, and the change in hamburgers is 1 minus 2, or 2 minus 1, and we'll end up with a negative 2 as our marginal rate of substitution. So we're willing to give up or subtract off 2 tacos in order to get one more hamburger, which is where the negative comes from. You have to give that up. We're losing that. So thinking about what we've talked about so far, which bundle would you prefer, bundle M or bundle Q? If you said indifferent, you've been paying attention. So they're on the same utility curve, which means that they're going to yield us that same 200 units of utility no matter what. So we really don't care. We're indifferent between the two. And again, the ultimate choice is going to end up depending on prices, which we'll throw in later when we talk about budget lines. What about looking at bundle M versus bundle P? If you said bundle P, then you've been paying attention as well, because bundle P is on a utility curve that's to the right of where bundle M is, which means that we're going to get higher satisfaction being over at bundle P. And again, it'll all depend on, do we have the ability to buy 5 tacos and 5 hamburgers? So the concept of a budget constraint, we're looking at the price of one product multiplied by the quantity of that product. So how many can we get? plus the price of another product multiplied by the quantity of that product. Again, for our purposes in the lecture and the book, they're using hamburgers and tacos. So we're looking at the price of hamburgers multiplied by the quantity of hamburgers plus the price of tacos multiplied by the quantity of tacos, and it has to be less than or equal to our budget. Now again, we're operating, for the purposes of our class, we're operating under the assumption that we're going to spend everything that we have. So our goal is to make our budget line end up being that we have used up all of our budget. So your real goal is to get as close to that budget as possible. And to do that, we're going to end up having probably 0.2 or 0.3 or 0.67 of a hamburger or a milkshake or a taco at some point. And I know that sometimes frustrates students. You can't have half of a milkshake. Well, in our theoretical world that we're currently learning in, yes we can, and we're going to end up doing that. So when we look at some of these budget lines later and in the next chapter or the next lecture, you'll see that sometimes on the homeworks they won't always come out even either. So keep that in mind. So what we're doing is we're looking at how many hamburgers can I have and how many tacos can I get given their prices and how much money that I have. So the budget constraint is going to limit how much you can spend on these items. And the graph is going to be referred to as the budget line. The slope of this line is going to be negative the price of hamburgers divided by the price of tacos. So here's going to be our example. If we have tacos at 50 cents each and hamburgers at $1.25, I want to know, if I don't spend any money on hamburgers, how many tacos can I get? So I'm going to take 5 divided by 0.5, and that's going to give me 10 tacos. So if I don't spend any money on hamburgers, I can get 10 tacos. If I don't spend any money on tacos, I can get 4 hamburgers. And then I'm going to buy 5 tacos and 2 hamburgers in order to continue to use up all $5. So our whole goal in this case is to use all $5. Now I'm going to teach, when we draw our budget lines, we're not going to have a point in the middle. We're going to take the 2 and find the 2 end points. So we would say, if I spend no money on hamburgers, how many tacos can I get? Well, and with when we talked about our plotting before, what that means is I'm saying 0 of nothing, so I'm going to have a dot on my axis, on my y-axis and on my x-axis, and then I'm going to connect the 2 with a line. So that's where we're coming when we're trying to plot these 0, 10, and 0, 4. So, let me see if I can draw. Maybe not. Here we go. Alright, so we're going to have tacos on one side and hamburgers on the other side. And let's see, we said our budget was $5. And tacos cost 50 cents. And then hamburgers were $1.25. So if you remember from the previous chart, if we said we had $5 to spend, we were going to buy all tacos, we could buy 10 tacos. So what I'm going to do is I'm going to put a dot up here, and I'm going to write 10. And then I've corresponded the taco amount, my budget, on the taco line. And then we're going to look at hamburgers. So if we spent 0 money on tacos, I can buy 4 hamburgers. So I'm going to put another dot here. And label that with a 4, and then my budget line would be to connect the two. And that really is supposed to be a straight line. It's slightly difficult to draw straight lines on the computer, but you can make yours a straight line. If you have to use straight edges, please feel free to do so. But it really is supposed to be a straight line. So this is how to draw a budget line. So your goal is to find out the quantity of tacos and the quantity of hamburgers that you can buy given your budget or your income, and then the price of the tacos and the price of the hamburgers. Put those on the graph and connect the two lines. And I'm not looking specifically for you to have perfectly spaced 1, 2, 3. I'm not really looking for that. I want you, this is what's important, is getting this 10 and this 4 number, and knowing that when you draw a straight line between the two, you've then created a budget line. So in summary, consumers rank their preferences based on utility or satisfaction derived from consuming that particular good. Businesses spend millions of dollars on product research because they understand the concept of utility and satisfaction, and a budget constraint is going to limit the amount of a particular good that we can buy. So even though we have all this satisfaction that we have derived or come up with given these products, there still are limiting factors that will put a consumer on a different utility curve or indifference curve. So price is always important. Next week we're going to look a little further at indifference curves and the budget constraint. We're going to put the two together and try to decide where our best option would be to decide, and then hopefully from there go into the concept of consumer equilibrium and demand curves.